Hello, everyone. Thanks for tuning in. My name is Amir Sharif. I'm the VP of Product and Marketing here at Opsani. And with me is Mr. Chris Lee, one of our star engineers. Good to have you, Chris.
Hi, glad to be here too.
So, Chris, can you tell the audience a little bit about yourself and your work history?
Hi, my name is Chris Lee. I'm the principal engineer here at Opsani. I spent about 10 years in VMware. I write the USB component of VMware and make the first virtualization USB webcam working in the VM.
That's impressive. I was at VMware at the same time as you. As I recall, you worked all the way from the virtualization layer all the way to devices on the USB stack. So it's a full stack development.
Yes, we virtualize from the virtual hardware device to how we talk to the backend and the physical USB drivers and all that. Yeah, it's a full stack.
Well, it's wonderful that our paths cross here again in Opsani. What classes of problems are you working on here?
I'm here working on the performance software, specifically it's the Kubernetes pod autoscaler.
And can you get into the details a little bit? What about the Kubernetes pod autoscaler?
So the Kubernetes horizontal pod autoscaler is actually a service offered by Kubernetes already built in. And you were able to scale up the number of pods when certain matches indicate you need to scale up. And that matches typically by default, it's a CPU utilization. You see, oh, this CPU is too busy, and then let's have more pods so that to distribute the load. And you can also use some other custom matches and also external matches to indicate when you want to scale up.
So the HPA, or the horizontal pod autoscaler, uses typically the CPU as the default metrics for knowing when to scale things up and down.
Right, that's if you don't go to the fancy way of like just, I want to automatically horizontal autoscaler. But by default, it will go into the CPU.
Is it possible to use other metrics besides CPU utilization, and is it easy to do that?
It's possible to do it. It's called a custom matches or external matches. Custom means it's the matches you use is still inside the pod. But if you want to use matches outside the pod, like from Prometheus or something, and then you will use external matches. And those have some adapters. You need to work with how to set those up. I would say it's not very straightforward, and it's actually not very well documented as well, but you can set it up, after some effort.
So there's some operational difficulties with HPA as it is shipped.
Yes.
Okay. And then based on our conversations previously, I understand that there's a performance target above which the HPA then creates new instances and below which it destroys those instances. Mm-hmm. How good is the HPA at setting that target?
HPA itself, it doesn't know what target to set. It's actually by the customer who uses HPA to set this. And the way HPA works, just look at, it's a watermark. And if it's too high, and then they will add more pods to distribute loads too low and then scale down. But how to set up that watermark is very, very sensitive. And if you set that target too low, it means that it will always, very easily, normal operations will overwhelm the packet, and then it will try to scale up many, many pods. And then you're basically running at your maximum capacities all the time. But if you're setting that target too high, and means that your normal operations and not able to scale up, you hit a very high load, but to the pod autoscaler, that load is not high enough. It's not worth it for me to scale out new pods. So it's always running at the minimum pod numbers. So how to set that value is have to learn how the app behaves and to set that properly. A lot of customer we see is that because they don't know what value to set, And this value might change over time by different applications and serving different contents. And then some of them, they just left the HBA set at maximum, and they configure HBA, but yeah, always running at full capacity.
And which means that you consume a lot of resources.
Yeah, you pay a lot of money for it, basically.
Yeah, because we're now in the age of cloud and everything's operational, so if you consume a lot of resources, you're paying this higher bill.
Yes.
Okay. Is there a performance problem? I understand the system's dynamic. The HPA scales things up and down. It goes above and below the market line, the watermark line. Does that create operational problems for the application itself?
That's the second thing I observe is that during the HPA scale up, there typically be a time lag between the pod able to respond to the new, let's say you decide to scale up right now. And then the pod will get the new additional pod will get deployed, and then they'll start taking requests come in, but they still take some time for them to run the service. It's like put up Windows, they need to put up a pod, and then they need to warm up their services because their cache, the cache is all clean. They need to start accumulate more data to accumulate cache and all that. So it takes a while for the pod really able to handle the service as good as the old one. So during that time, pretty much the old pod, the poor old pod is still taking the heavy beaters. Even though the traffic is rising up, they are still the one that taking the most of the hit. And that's where the immediately scale up of the pod doesn't immediately address the increased load to the old pod.
Okay, so then from what I understood is there's basically a lag time that's created.
Yes.
And therefore, even though the demand on the application is going and its system's responding, but in that upswing cycle, the application is not responding the way it should be.
It basically means that the new pod, even though it's created, but it's not serving as many requests as we want. And the old pod are forced to serving more than their capacity can handle. So the performance will go down. The user experience will run bad. Basically, typically the service latency will increase, and they see a page take much longer to load, and that kind of stuff. So in a lot of customers, in order to solve that problem, the easiest way is they just make the watermark lower, so that the pod will automatically scale up higher, and which also means that they will always have some spare pods there just to prepare for these upswings. And if you don't have these upswings or past upswing cycles, then those pods are not doing much. To address the performance lag problem, you're consuming a lot more resources than you need to. Right. It's just to handle the sudden uprise.
Okay. So what happens on the downward path? Now, if there's a watermark level, application demand drops, it goes below the watermark level. What happens at that point?
Because you use the same watermark for the scale up and scale down, and typically, if you need to set the watermark low, which means that when you don't have much traffic, you still have those spare pod running. So it's also, it's basically wasting money on.
Again, it creates waste.
Yes.
So, okay, now you're here at Opsani, you're working on the autoscaler problem. You outlined the three problems, which is difficult to define resources beyond CPU utilization, setting the watermark correctly, and then the inefficiencies that's caused when you're on the upswing or downswing. I assume that you're solving these problems here at Opsani. Do I have that right?
Yeah, of course. That's why I'm here. So I'm actually very excited to use some kind of machine learning algorithms to study how the application perform in relate to the requests, the volume of the requests they are taking. And the AI algorithm will figure out the best way, what was the hidden relationship between those, and what was the best moment to scale up, and what was a proper value to scale up, so that it can both serve the pod when the high traffic comes, And also, when there's not much traffic, you can scale down to pretty low and save money. So basically, the customer doesn't need to worry about where do we draw this line and how to set those value. And Opsani AI software will able to do that automatically.
So it's the automatic watermark setting and the predictive analysis of when load will go up and down, so you get the optimal resources dedicated to you. Do I have that correct?
I wouldn't even call that watermark inside. It's the AI algorithm that they figure out what was the right thing to do. Internally, they may not even have a watermark. It's just they analyze the data, what is the right way to scale up, and what's the corresponding to the predicted serve capability in relation to time, etc.
When you were initially describing the problems with HBA, it came down to costs.
Yes.
The cost of not having the system respond right, the cost of setting the bar too low, the cost of the system going below the line, and using.
I would say performance and cost. Because you cannot say one without the other. The hard part is actually how do you meet the performance requirement that you don't get a page loading take too long, for example, and also cut the cost. If you just want to cut the cost, you don't care about performance, that's easy.
Well, what I do know from our field engagements is that customers save typically at least 30% on cost and improve performance by about 80%. Does that match your observation?
Yes, we see because this high rising on the traffic volumes, and the customer need to have a lot of headrooms to reserve for the auto scaling. We see 30% or to 50% is a typical case that the headroom they want to reserve to handle the auto scale up.
So in your own words, what do you think the pragmatic or the business value of your work to our customers is?
Our work to the customer would be, we were able to meet the performance requirement, and we're able to figure out when's the right time to scale up and when's the right time to scale down. So we can eliminate those hard headrooms set by the customers, and we can get those like 30% money back while keeping the performance goal needed.
So good performance at a lower cost, basically.
Yes.
Well, thank you so much for doing this. I mean, it's I'm really excited to be working with you again, and it's really nice that you're solving these complex set of problems. And I know that we have a pretty busy roadmap, so I'll look forward to having another discussion with you when you start solving the next set of problems.
Yeah, I'm very glad to be here. Yeah.
Well, thank you everyone for tuning in to the Opsani webinar, and look forward to seeing you in our next instance.
Okay, Chris, there are a few customer questions that are coming up, or rather audience questions that are coming up. But first, the first comment was that the audio quality was not the best. We will fix that in the post-production. And here I see a few questions popping up right now, Chris. The first one is, why is lag bad for workloads? And just how bad is lag? And can you talk about the impact on the business problems?
Oh, sure. I assume the lag, you mean that when you start up the pod and then it takes a while for the pod to able to handle response. And it's typically bad for controls. Is that control system, if you have a long control latency, and then make the control a lot harder. So for the customer point of view, they are easy workaround is just to increase the number of pods. So overall, the lag cost the bad customer experience and also waste of money.
So basically, it's the hard to control aspects of it that ruins the end user experience, while increasing cost for the customer or for the business.
That's right.
All right. So we go to the second question. And the second question is, it's related to what we just talked about. How is the Opsani predictive load balancer differentiated from competitors?
Our load balancer, or the predictive load balancer, it actually doesn't need to set those targets, like doesn't have these hard to set targets, and then you need to reserve the headroom. So it's a lot easier to use, and at the same time, you get very good performance and saving monies.
So we're differentiated by being easier to use and producing better results.
Yes.
Excellent. We go to question number 3. How does the Opsani predictive load balancer complement our current capabilities?
Our current capability is mostly optimized for per unit. So we get the best output for per unit operations. And the autoscaler we are talking about here is actually working at a different aspect, is how to combine this best per unit performance to scale out. So it's the dynamic behavior of optimal.
Okay, very good. And there are a couple more questions that have come up. One of them is, this is about the classic PIT algorithm that you mentioned earlier. So using the classic PIT algorithm to control Kubernetes HPA or the horizontal autopod scaler, that's what the question is asking about. Is can you elaborate what the PIT algorithm is and how it interacts with the HPA?
Oh, the PID algorithm, or PID, or proportion, integral, and differential, it's a very popular black box control algorithm, and probably most of the thermostat use that kind of stuff. It doesn't require to understand what's happen under the system, like the system behaviors, and then you just use a couple parameters to set to tune it. It's very popular. It's easy to use, like without too much theories, but it requires a lot of tuning. And for us, that because the PID control algorithm doesn't able to fit different pod behaviors, like different customer, they might have different pods and they behave differently. So it's actually very hard to come up with an algorithm to automatically tune that. The algorithm we have is a lot more advanced than PID, and it will figure out what's the right thing to do at the right time. So you would get much better performance than PID.
Okay, so again, the answer comes down to better user experience. In this case, the user is a developer and more control and better results, better business results at the end. So which brings me to the last question that's on the screen. And the question is, do you have any specifics with respect to cost savings? For example, meeting the performance that needed X dollar savings. That's an excellent business question that's coming from the audience. Generally, what we see in a customer, of course, it varies from customer to customer. And typically, a customer sets a particular performance target, and then we find the optimal cost-saving solutions for that target. However, even after the customer sets a target, we often exceed what the performance targets are, cutting the cost by half. So 200% increase in performance and 50% cost reduction. And those are outstanding returns that even though we meet the goals, we typically exceed the goals and we cut the costs substantially. Again, that varies from customer to customer, but that's a good ballpark average, 2x the performance at 50% the cost. And at this point, I think we've answered all the questions. So with that, I want to thank everyone out there, all the audience, and ask you to tune in again for our March webinar, which will come up in approximately 4 weeks. Stay tuned to Twitter, to our Twitter feed, and to our website to see when that's going to go. Thanks, everyone, and have a wonderful day.